Thank you for joining today. I'm Tanaka. I talk about mruby/c3, which is mruby for smaller devices. I talk about this point. My name is Tanaka. I'm an associate professor in Kyushu Institute of Technology. Of course, I am a mruby and mruby/c developer. Usually, I have lectures about data structures and algorithms and robot sensor processing and so on. So I am mainly lecturing about information science, computer science, and also I have a research related to the embedded software. This is, of course, this is about mruby, and also low power wireless communication and its protocols, which is called LPWA. I usually do such works. Before talking about mruby/c, I'll talk about mruby, the mechanism and the execution style. So mruby is one kind of Ruby language, and mruby is usually compiled to the mruby bytecode that is called mruby file. This is device-independent code. This code, bytecode, is loaded to the mruby virtual machine and execute the bytecode step by step. This is mruby. Next is about mruby/c. This is the pronouns mruby/c. So the mechanism is almost same as mruby. That is compiled, generated bytecode that is executed on the virtual machine is the same. mruby/c is another implementation of mruby virtual machine. So the bytecode is exactly same as mruby, of course, because mruby compiler is the same compiler I'm using. And bytecode execution, that is the virtual machine, is different. And this is a point of the mruby/c. So another implementation of mruby virtual machine. Then, what is the difference between mruby and mruby/c? The concept of mruby/c is following 3 points. The first is mruby/c is supporting various CPU, various architectures. A smaller CPU and larger CPU is anything okay. And also the porting is very simple and very easy. Just rewriting several lines, very few lines. That's all about the porting. Next point is mruby/c requires small memory. Minimum is 8 kilobyte, but maybe 8 kilobyte is nonsense. 16 kilobyte is very popular as the minimum. And larger is anything okay. So mruby/c consumes a very small memory. And also mruby/c is has a concurrent execution mechanism. And this is called multi-programming. Several programs are implemented and execute them concurrently. That is a concurrent execution. Okay, next is mruby/c3. This is the latest version of mruby/c. mruby/c3 is supporting several features. First is static string and static symbol. This is contribute to the memory consumption. And next is newer opcode in mruby3. Previously, I talked about the difference and same point between mruby and mruby/c. So the bytecode is exact same as mruby and mruby/c. So mruby/c should support the new opcode in mruby3. So we are supporting this point. And upgrade point is newer virtual machine structure. This is the internal structure of mruby virtual machine upgraded, and newer memory allocation algorithm. Algorithms are also almost same, but newer implementation of memory allocation functions. This is contribute to the memory consumption and allocation speed. Currently, MRC3 branch is released in the GitHub. I talk about the porting to any devices. So almost all of code is device independent, just C language, very portable. And last few percent of this code is device dependent. So about 0.3% is dependent. So we must rewrite or we must implement this device dependent code importing. So more details about the porting, we must rewrite 6 functions. These functions are listed here. HAL related functions. HAL init is HAL initialization. HAL is hardware abstraction layer. So hardware dependent code is concentrated here. So HAL enable IRQ and HAL disable IRQ is enable and disable of the interruption. And HAL idle CPU is so that is waiting 1 millisecond. This is a waiting function. And HAL write and HAL flash is this is a standard out of the to the console. So just rewrite the 6 functions. That's all about the porting. And also we provide several HAL implementations for the USB 3.2, that is one microcontroller board, and PIC24 and POSIX and PSOC 5LP. Several HAL is already provided. Maybe you can refer these HAL functions, then you can rewrite the HAL functions for your own devices. They are target devices for mruby/C. They are very popular in our development. And we also provide IDE. So this is a development environment. mruby/C is supporting concurrent execution. So please look at this red circle. Several mruby code is listed here. So this listed code is executed concurrently in target devices. Okay, let's move to about the memory management. This slide and the next slide is very related to the technology and very detailed of mruby/C. About memory management of mruby/C is using TLSF algorithm. This algorithm is very fast, and the computation order is order 1, so very fast. That means very fast. And also the mruby/C is focusing to the many target devices. So some target devices is dynamic memory allocation mechanism is already implemented, like Windows or Linux or something. But some kind of real-time operating system is statistical memory allocation is supported. That's all. So mruby/C is supporting such statistical memory allocation. And fixed memory, this means RAM is fixed and address is fixed. So constant address is necessary for the initialization and so on. So mruby/C is supporting several type of memory allocation. So mruby/C requires only 2 points in execution about a memory. So starting address and memory length, that's all. That's why. So mruby is adapted to the many kind of memory allocations. So mruby is has own memory allocation mechanism in virtual machine. This is the result about the sample program. This program is very simple. So first, the empty array is assigned, and adding 100 numbers to that array, and print the array. So memory consumption is 7,400 bytes. Use memory you can see. And also a good point is memory fragmentation. That only 3 fragmentation is occurred in this sample program. So very few. This is a good point of the memory allocation and memory management features in mruby/C. This is another result of the sample programs. There are 2 programs. Left side is 100 entry of the array. Right side is 200 entry of the array. The difference is number of the array, size of the array. Okay, and memory consumption is also of course different because the number of the entries element is different. But the difference is exact same as element of the array. Difference element of the array. So one element of the array is 16 byte, and the total difference between 100 and 200 is 1.6 kilobyte. That is exact same as 100 elements of the array. So this mruby/C memory allocation feature, memory allocation algorithm is a very good point in the memory consumption. This is very good at memory usage. Thank you for listening today. There are references of the mruby/C. Of course, mruby/C is open source software, so we released and we opened in GitHub this site. And also detailed or some references or documents about the mruby/C is released from this site, following site. So please refer these references, and if possible, please use the mruby/C for your work or your researches and so on. Thank you for listening again.